So what we did last time, let's check. So we started the linked list. We completed the function get last, get first, clear, shift, and the print method. Okay. So let's complete all other functions today quickly, and then we'll go further. Okay, let's go to this page. So whenever we create the linked list, we have the head, which is initially pointing to null. And if we add element in this head, so this element is kind of object which has the value, and it is the pointer, next pointer where it is pointing to. And this object is created by calling the node class, and node class will take the value and the next parameter. So if I want to create a new element, first I will create the object using this class, and then I will put the object here, and this head will be pointing to this object. And if we are trying to add one more element, we create another object and put it here as the next of this one. If we want to create new object, I can create that object before it also, after it also. If I create before it, it is called unshift, and if I create after this, it is called the push, as we do in the array. So let's think I have this element. These are the objects in my linked list, and the last one is pointing to null. Now question is how we can travel from this to this, this to this, this to this, and this to this. So we have to create a variable called as current, which will initially point to head. That means it is pointing to this 30 number. And then we can read the value 13. Once I read the value 13, my purpose is solved for this one. Now I have to move this current one to next one. So I will say current is equal to current dot next. Once I say this statement, my current will point to this one, because current dot next is this one. Again I will read the 4 number wherever I want, and then again I will call current equal to current dot next. So current will move here. Again I will read the value wherever I want to read. Then again I will call current equal to current dot next. So current will move here. Then I will read the value of 2 here wherever I want. And then again I will say current equal to current dot next. That is the null. And once the current is become null, I will come out of the loop, and I will exit out of the function, and I have read all the values. So this is the one thing which we do generally, the traversing the linked list. Now I will ask you one question now. This is my head. This is pointing to the first element, that is 13. Then it is pointing to the next element, that is 4. Then it is pointing to the next element 2, and then it is null. Now if I assign this to current, I want you to tell me, I want to create another element. Okay, let's make this little bigger, otherwise we won't be able to see the real effect. Let me make this bigger. Chain 1, then we have 2, then we have 3, then we have 4, then we have 5, then we have 6. Okay, let's have 6 elements and null. Tell me, if I point to current, I have to traverse through this linked list, but I want to traverse with 2 variables. One is called current and another one will be the next, which will be pointing to this one. As current will go this one, this next will go to this one. So current will travel this one and next will travel to this one. So next will become this one. And then again current will go this one, next will go this one. Current will go this one, next will go this one. Current will go this one, next will go this one. Current will go this one, next will go to null. So like this we have to travel. So if my current is this one, what will be my next value? So that it should point to 2. What should I put next is equal to, so that next is pointing to 2. I have current in my variable list. Current is pointing to head, that is this one. Now tell me, what should I put next so that next is pointing to this one? Everybody try to answer it. Okay, so Rakesh has given the correct answer. Next will be current dot next. So current dot next is 2. So next variable will be current dot next. We will not use push because push is already used to enter all the elements of the linked list. So push does not make any sense. C+1, nothing is C+1. There is no C+1. Current is pointing to 2. There is, see, I put 1, 2, 3 number. That doesn't mean C+1 is going to this one. Tomorrow the numbers are different. So current has 2 parameters. Current is object. It has 2 parameters. One is called the wall. Another is called next. Wall is nothing but this value. And next is pointing to 2. So if I want some variable next, which is the current dot next, so I will assign next equal to current dot next. Now after I assign next equal to current dot next, I will do something. Blah blah blah. Maybe I will take current value, multiply it, do something. I will take next value. I will take the next value, do something. Blah 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 blah. I'll do something. And the work of current is also done. One work of next is also completed based on my logic. Now I want to move current to 2 number and next to 3 number. So what should I say? Current, what will I put current? Once I am done with all the process, I want to move now current to 2 number. What should I say current? Current equal to? Currently, current is at 1 number, next is at 2 number. But now I want to move the current to 2 number and next to 3 number. What will I say? Current equal to what? I have to move current to 2. Right now current is at 1. So this part is done. Now current equal to current dot next is one thing. This is right, but any other thing which I can write so that current moves to 2 number? I can say this. This is perfectly right. But since we have next variable also, Is there any way I can change the current equal to something so that current moves to this number? Current plus 1, there is nothing plus 1. This is object. You cannot add 1 plus 1. This current is object of value and you cannot add numeric value to the object. Current is the object of value and next. Current has the value of 1 and it is pointing to 2. That is this 2 object. I can, if I want to move current to this 2, I can say current equal to current dot next. That is right. But based on the information I gave you here, can I say differently current equal to something which then also current will move to this number? Push is not needed. I told you push is only to insert the elements. Now that phase is gone. We are not pushing. We have to move. Push is only needed in the initial phase when I try to add all the elements. But now we just want to move. And I want to move current equal to 2. This is right. She is right. Kate is right in saying this one. But I want another method. Though I can use this one and I can move. But I just want to make you understand that there is another way also. Can I say current equal to next? Yes or no? Can I say this? Rakesh is saying yes. Anyone else? Maybe yes means you have not understood. So I'm saying maybe yes. Either say yes or no. Ole is saying no. Anyone else? Okay. So the answer is yes. Since next is already pointing to the current dot next, based on this information I have written here. So current equal to next is also right. So it is yes. Let's try to write down again. This is, for example, 13. This is 4. This is 3. This is 2. This is 1. And this is null. So this is head. Point to this. I will say current is here. And current dot next. Next is what? Next is what? Current dot next. When I say this 13, here 13, that means current is object which has the value of 13 and another key is next, which is pointing to this 4 number. So this is the current object. It is object. It is not the value. I cannot say 13 plus 7 or 13 plus something to get this one. So this is the object. Current is object. Remember that. It is not the simple value. It is not array. It is not string. It is not numeric. It is object, which has the key of value with the value of 13. And next is the pointer to 4. So my next is this one. Current is this one. Now I want to move the current to this 4 number. So I can say current equal to next, because current next is nothing but current dot next. So I can say current equal to next. When I say this line, current is moved here. So this will become current, which is next is also this one right now. Both are same. Now since current is moved here, I want to move next to this point. What should I write here? Next is equal to what? Current dot next. Current dot next, right? Correct. Next is not equal to current. Next is current is here, and we want to move next here. So next will be current dot next, not the current. If I say current next is current, then both will be same. So we have to say next equal to current dot next. That is, next will be pointing to this one. Now C is here. Now I have to move current to this point. What should I write here? Current equal to next. Correct. When I say current equal to next, current is moved to here. But next is also here right now. So I want to move next to this point. What should I say? Current equal to next is there. I want to move next to here. Next equal to current dot next, right? Now next will point to here. Current is here. Now I want to move current here. What should I say? Current equal to next. And current will move here. Next is still here. I want to move next here. Next equal to current dot next, right? When I say current dot next is this one. So next will be pointing to this one. Now I want to move the current here. Current equal to next. Correct. This is the current equal to next. So current will move here. Now current and next are both here. Now I want to move next to this. So next will be null. We don't know null. Null is the variable. Next will be, we don't know it is null unless we read it. So how to read the next? Current dot next. And current dot next is null. So next is point to here. And then if I want to move current also here, I will say current equal to next. Now both are at the last point null. Both are null. So this is how we traverse the two variables together one by one. Like this, we can create third variable also, which will be at the third number, and things will become more complicated. Okay, that's not the point right now. Now let's start again. This is head. I want to add element in this head. Right now it is pointing to null. Since I want it is empty, I want to create object and point head to that object. So what is the first step I have to do? What is the first step I have to do? It is head is pointing to null. I want to add one object in this linked list, and head should point to that one. So what should I do? What is the first step? create object. Create object. And how to create object? From the node class. And node class is nothing but it has the value and the next pointer. So if I want to create a new object, I will put value whatever I want, for example 13, and the next will be null. So this is my new object. It has the value of 13 and it has the next value of null. So I will create this object and change the variable value head to this one. Initially it was null, so I will cross this one and I will update this head to this value. So now head is nothing but this object with 13 and pointer to null. Now I want to add one element, more element here where it is null. Okay. So let's delete this part again. Now I want to add one element here at the place of where we have null. We have to push it. Since we have to push it, that means we have to push here. Here. So what is the first step now I have to do? How to push? How to push? I'm creating push function, for example. So in the push function, I have to add the element at the end. That means in where we have the null, I have to add element here. So what is the first step? Say something. Right now I don't have get last in the screen. Okay, so don't worry about get last. We have to build that actually get last. Where is the push function? Push dot null. What? Push is nothing. I'm not talking about push right now. Push is the name of the function, but I cannot call push. Push is no object, no variable, nothing. I cannot call push. I have one object, so let me write down again. Maybe you're not getting it. Okay, so let's go again. This is my head. Initially it is null. So I will create one object which has the value of 13, pointer to null, and I will say head equal to this object because head is assigning to this object. So we created one object. So head is now pointing to this object. This whole is the object. Now I want to add one more element here in place of null. That element is nothing but, for example, 4 with the pointer to null. This is a new node I created. Now I want to replace this null with this object. Okay, so what we did, we created this object. So what was the step? We create object. Now I have to change this null with this object. I have to update the null with this object. So what I will say, I have to traverse the end. I have to say current equal to head. Okay, and then I will check if current dot next exists. Is current dot next exist or no? Is current dot next exist or no? Current is this one. Does current dot next exist or no? What is the current dot next? Those who this 4 is new object. It is not related to current now. I said this object was created, but I haven't replaced it with the null. So this is not the current dot next. Does current dot next exist or no? Again. So yes or no? Answer is yes or no. What is the Shweta? What is the value of current dot next? It is null, so it doesn't exist. Right? Null means it is not there. If you write if current dot next, will it give you some value? No, that means current dot next does not exist. If current dot next does not exist, so we have to write current next is equal to new node which we created, the new node. So when I say current dot next equal to new node, this node will be attached to this null place. Okay, so let's write down again, which will help us. So this is head. Initially nothing was there. I created this object 13, and then it is pointing to null. Then I want to add one object more here. So I will make this current, and I will check that current dot next is there. It is not there. So I will say current dot next equal to new node. And what is new node? New node is nothing but a 4 with a pointer to null. So this is a new node. So current dot next will become this one. So this null will go away now. This null will go away, and we will get this one here. So this one will become 4 and pointing to null. Right, Kate, you're right. Okay, so let's delete it now. Let's delete this part also. Okay, now we got our linked list like in this format. We have 13, 4 and null. Now I want to add one more element. I will point this to current. Then I will check current dot next exist. Yes, current dot next exists. So I will change the current equal to current dot next. So current will move to here. Current has become this one. Now again I will check current dot next exist or no. Did it exist now? No. So I will say current dot next equal to new node. And what is new node? It may be an object of value of 5 with pointer to null. So I will say current dot next equal to this part. So now this null will go away, and we will get this object. We'll get this object here. So here I will say 5 pointing to null. So this is the way we will go and travel, and we will try to add the element at the end of the linked list. Now let's try to do this practically. So first thing is we need to create this function node. So I will create a function node. It has value, and the next will be initially null. If I don't pass, it will be the null. Now I will say this dot value is equal to wall. To create again, I by mistake press enter, and I will say this dot next is equal to next. So this is my function. Let's say initially I create one variable head which is pointing to null. Now I want to add one element in the head, which is this object of this class. So let's first create the new node from this function. So how to create new node from this function? Can anyone tell me? What should I write to create a new node from this function? How to create new node from this function? There is no push here. Push is only created in the array. I want to create new node in this from this function. Okay. New node, right. So Kate, forget about head right now for 2 minutes. Let's put the value part, new node, and I will put 13 number value, and the next will be null. So I create this new node, and since initially the head is null, it does not have any value, so I will assign head is equal to this one. Since head is null, directly I will say head equal to this one. Now what will be the head? Head is an object which has 13 number value and null, next is null. It is similar to this 13 and it is pointing to head. Now I want to create 4 element after 13. Okay, so we need to create this part. Okay, we already have head. Now what should I do? I have to traverse the head till the end, and then I have to attach to the last part, the new node. So let's say if I want to create a new node, I will create a temporary node. Maybe I can say my new node is equal to new node. Let's say I put 4 number with the value of null. So this variable new node is having the object of this node with the value of 4 and next is null. If I want to see new node is equal, what is new node? It is the value of 4 with the next of null. Now I want to take this new node and I have to update this new node with the next. So next should be this new node, because next is null, it should point to new node. So it will be similar to, after 13 we have 4, that will be similar to that one. So new node is created. How should I attach that to this next part? What are the steps? What should I do first? We said we have to create the object which is created already here. I created the object here. Now how can I go to the next one? Right, we have to create the pointer. So let's create the pointer current, which is pointing to head. Correct. Var current equal to head. Now current is nothing but the head. Now we have to see if current dot next exists. Does it exist? It does not exist, right? So what we have to do? Current dot next is equal to what? What should I say? Current dot next equal to new node. I have to put new node. Correct. Now if I check the head is 13 and it has the next value of 4, which I added here. Though I added in the current, because JavaScript always runs by pointer, so head is also changed to the same way. Okay, so you will be thinking we change only the current dot next. How head got updated? Head got updated by the reference, because everything is by reference in JavaScript. So head got updated. Now we have head like this, 13 and then 4. Now I have to add the new object here in place of the null. So what is the first step? First step is to create the object. How to create object? I will say var new node is equal to new node. Previously I put 4, I will put 2 now. So new node is created. Okay, so now new node is created. We have to attach to this next part, this part. So how can we do that? So we will again start with the procedure. Let current is equal to head. So now current is, var current equal to head. Okay, now current is pointing to head. Now we will see current dot next is there or no. Current dot next. Current dot next exists. Since current dot next exists, what will I do? I want to move the current to the next one. What should I do? Since current dot exists, this one, current equal to current dot next. So I will say current equal to current dot next. Again I will check current dot next exists or no. Current dot next does not exist. So what I will do? I will say current dot next is equal to new node. Now if I say check head, it is 13. Then we have the 4. Then we have the 2. And then null. So this is how we traverse till end, and then we add the node in the end. So let's try to do this in the coding now. Since we are adding in the end, we will be using the function name as this.push, and it has the arrow function. Now here I will put wall. So since we have to push till the end, I can call this getLast function also, but let's try to do it manually here. Let's try to do this code, same code here in this push part. So tell me, if we don't have head, what should I do? What will I do? If head is not there, that means head is null. That means our linked list is empty. What should I write here? How can I add the element if head is null? Head is equal to new node. Create object, correct. So I will say this dot head is equal to new node, and I will pass the value, and I will say next is null. Correct. If head is not there, then I do like this. Let's try to run this one and see. So I will delete all this one. I will just say list.push and put some value 13. Since this is the new linked list, head is empty. When I try to push it, I will be able to update the head with the new node. So let's try to run this and see. So right now I'm only calling push. I'm not using any other function. I'm only calling the push one. Checking if head is not there. I am trying to create a new node, that is new object, and assigning to the head. So as soon as I assign the head, you will see when I run the print, I was able to see that 13 value here. And if I try to see the list, it will have the head as the value of 13, next is null. Now we already have the one value. If I try to add more, if I try to add more now, for example, list.push of 4, this will not do anything. Why it will not do anything? Because we have only taken care of if condition. We have not taken care of condition where head is there, then what to do? So if head is not there, I just create the head and I will return the thing. Return. I don't need to do anything. But if head is there, then what should we do? What is the step? Create one point. Correct. That is let current equal to head. This dot head. Now what? Now current is pointing to head. Now we have to check if current dot next exists or not. So I will say while current dot next, if current dot head next exists or not. If current dot next exists, then what should I do? If current dot next exists, then what is the step? Current equal to current dot next. Correct. We have to move the current to the next part till the end. We have to say current is equal to current next. That's it. Then again it will check current dot next exists. Yes. Do the current equal to current dot next. Then again it will say current dot next exists. Yes. So it will do current equal to current dot next. If it does not exist, it will come out of the loop, and ultimately we have the current value. Let's see what is the current value. Okay. So first time we won't be able to see the current because head is not there. It will be written by here. But as soon as I call second time push, though it will not be pushed because we have not written any code, but at least we will be able to see the current part. Let's try to run this one. Okay, so first time it got added. Second time we are seeing the current is, so current will be 13, right? Because 13 is the only one in the linked list. 4 is still not there in the linked list. So current will be the last node which will be there in the list. So how will I update now the new node to this current? What should I write? We got the last node. This current is nothing but the last node because we traveled all through the till end. What should I write here so that new node is added to the current next one? Current dot next equal to new node. Correct. Rakesh is correct. Current dot next is equal to, since current dot next does not exist, that means it is null. So we have to update it with some value. Value is nothing but this one. And I will return it. This return is not needed actually because we are okay. So we put this current dot next equal to new node. After this step, a new node will be added. So let's try to see it now in action. So now 13 got pushed, 4 got pushed, and we see in the array 13 and 4. Let's try to add few more. So we have 13, 4, 1 and 5. So we try to push everything based on this one. So though push can be called by calling the get last, but since I want you to understand push again, so I have written the whole code again. So try to write down this push code. I will give you 2 minutes as this one. What you did? So we don't have to use if condition here since it can be many currents, so I don't want to use the if condition. In the while condition, we are putting current dot next to see if next exists or not. If next does not exist, that means current is the last one, and we have to update the current dot next with the new node. Okay, so I am giving you this node function in the React Telegram group. So just do this function 10 times and by heart this function. And then today we did push function. So try to by heart this push function also multiple times. Since it is fresh now in your mind, if you write down this function 10 times and try to draw the diagram on paper and page and try to relate this each line what you are trying to do with this image so that it should be clear how we are trying to push the things. Okay, let's further now. We did last time unshift. Let's try to do unshift again. This is the head which is currently pointing to null. Now I want to add element in the head. Since the head is null, I can directly create the object and say head is pointing to that object. So this object is like this 13 pointing to null. So what we did, we created the object and just point the head to this object. Now I want to add element before this one. Okay, at the beginning. So to add the element in the beginning, since I want to add the element, I will create the object. So let's create the object first. So I created this object. Let's say I want to create one object. It is pointing to null currently because I created object with the null value. But what I have to do, I have to attach this to the beginning of this one. So what I will do, I will say this new node dot next is equal to this one. Is equal to this one means what I should write down here? Head. So I'll say this dot head. Not value. We are not attaching to value. Never think that we are attaching to the value. Value is the part of the head, part of this object. So we will never attach to the value. So I will say this new node dot next equal to head because this is the head. And once we attach new node dot next equal to this dot head, that means the next value of this one is pointing to this one. Now currently head is also pointing to this one. What should I do head to head? That head should point to this one. What should I write? Head equal to new node. This is the new node because now head has to be point to this one. Head should point to new node. So let's write down the step which we have to do. So let me write down here. Okay, so this is my node. Let's say head is null initially. I will create a new object and I will assign to head by saying new node of 13 pointing to null. So now head is the value with value of 13. It has one value, one object inside it. Now I have to attach another one in front of this. So I'll create a new node is equal to new node with the value of 4 and pointer to null, for example. Then I will say new node dot next is equal to what? So that it should come before this one. So what should I do? New node dot next equal to head. Correct, head. Now if I see new node, it is 4 and then we have 13. If I see head, it is only 13. So what should I do? Change to head. What should I do head so that head should point to 4, not 13. Right now head is pointing to 13. What should I write down? Head equal to what? So that it should point to new node. So I will say head equal to new node. Now if I check the head, it is pointing to 4 and 4 is pointing to 13. That means we added the element before the current element. So we have did the unshift part, but it is too brief. Let's do unshift again by writing little more statements. So I will say unshift. I will create unshift 2 because this is little bit different. So what I will do here, I will say first I will create new node, var new node, or I will say constant new node is equal to new node with the value of val and next is null. So this will be the new node created, and then what I will do, new node dot next I will point to head. So I will say new node point to head, and then what we did, did new node dot next equal to head, which is this one, this dot head. And then what we did, we changed the head equal to new node. So I will say this dot head equal to new node. So this is something little bit bigger than this one, but this is the one line which is the same purpose which we did in the 3 lines of the code. So if you're not clear of this function, this makes more understandable that we are increase the number of lines, but it is clear. We create the new node. Currently it has next of null. So we change the next to the head because it should come before the head. And then we change the head to the new node so that next time we do, head should be pointing to this new node. Just write down this unshift function. New unshift function. Okay, let's go. Order is like this, no? We have to create a new node. In the unshift, order is like this. We have to create new node. Then we have to update the new node with the head, and then we have to update the head with the new node. What do you mean by order method? I'm not clear. I'm not clear on your question. Other method to add node. So this one will be added in the beginning. This push will be added in the end. And this unshift was a shortcut, which is also similar to this one. It will be added in the beginning. Okay. Now we have to remove the node. We already saw one of the method called as shift last time. You can go through this again, and I will also repeat this again in few minutes, but let's try to remove first from the end. Okay, so let's try to remove from the end, and then we will go again in the beginning one. I explained beginning one last time, but I will explain it again now. So this is the head. It is pointing to 1 element 13, which is pointing to 4, which is pointing to 1, which is pointing to 2, and which is pointing to null. So what I have to remove this element, okay, pop, and we are doing pop. Pop means removing the last element, that is this one. Since I have to remove this one, so this should point to null. That is the ultimate goal, because we don't want this one. We have to remove this one. So what we have to do, we have to assign this to current, and we have to assign this to next, as I told you in the beginning of the today. Then I have to move this current to this one. So current will move to here. So current will become this one. And then currently current and next are pointing to the same one. And next will point to this one. Then current point to this one. And next will point to this one. And current will point to this one. Next will point to this one. So like this we have to move. So let's try to move it and see what we achieve. So let's try to create the function node again. This dot wall equal to wall. This dot next equal to next. I will create one variable head, which is equal to null initially. Then head will be new node 13 with value of null. So head is this. Then again head dot next will be, again I will create a new node. We can call push, but right now I'm just writing it manually. Head is 13. After 13 we have 4. I will say head dot next is equal to new node. I'll say head dot next equal to new node 1. So if I check head now, it is 13. After 13 we have 4. After 4 we have 2. After 2 we have 1. Okay, so this is the one. We have the head with all the parameters as we write it here. So now we have to remove the 2. So let's try to go again. So what is the first step? I will create the current. I will go manually. Each step will be the manual. Current is nothing but the head. Sorry, I cannot do the late here. Current equal to head. current equal to head. So current is pointing to head. What we need, another thing is next. So I'll create variable var next equal to current dot next. So if I see current is 13. If I see next is the 4. As we see, next is 4. Now I want to move the current. I want to move the current to here. So what should I write down here? Current equal to next. Correct. Now current is 4. Next is also 4. Now I want to move next. So what should I say? Next equal to. So current is moved here. Now I want to move next to here. Current dot next. Right. Current dot next. Okay. Now again I have to say, I have to move the current. So I have to say current equal to next. Correct. So current is now at the 2. 2 is here in the example, 1 is here. So current is now 2. Next is also at 2. Let's say next is also 2. Now we have to move the next. We moved current already. So what should I pass? Next equal to current dot next. Correct. So next is 1 and current is 2. So current is here, next is here. Now I will not go further. Now I will check if next dot null exists. Since next has reached here, and current is this one, I will check next dot null exist. Does next dot null exist? Yes or no? What is this? What is it? Next dot null. Let's say next. What is next? Does next dot null exist? If I say next dot null, what is it? It is undefined. It doesn't exist. Sorry, next dot next. Next dot next is null. That means it is not there. Is it there or no? It is not there. So when we get this condition next dot next is null, that means where is the current? Current is here, right? When I say next dot next is null, that means current is here. Yes or no? Yes, because when next is here and current is here and I check next dot next is null, that means current is here. Now only thing, when I reach this point, only thing I have to do, current dot next equal to null. I have to change the current equal to null. Current dot next equal to null. When I say current dot next equal to null, this whole thing will go off. It will get deleted. So here, if I say, since I found next dot null equal to next dot next equal to null, here I will say current dot next equal to null. When I say like this, and if we check the head, 13, then we have 4. After 4 we have 2. After 2 we have null. 1 is gone. This one is gone. So we deleted the last one. So this was the manual step. Let's try to do this in the code. So I'll create another function. This dot pop. Pop means we have to remove from the end. I will put some if condition later next week in the pop, but at least if we have more than 2 elements, we will try to work with that condition. We will assume we have more than 2 conditions. For other condition, we will see how to fix that one next time. But let's try to consider we have more than 2 elements in the linked list and we need to remove the last one. So I will create one variable called as current, which is pointing to head, and then I will have another variable called as next that will be pointing to current.next. Okay. So now what I will do, I will run the while loop. Till what time I have to run the while loop? When I will say next should be there. If next is not there, then I don't want to go inside it. But if we have next, then we have to follow the step. We have to move one by one. We have to move current to 1 and next to 1 level. Okay, so how to move it? I will say current equal to next, as I showed you here. As I showed you, current is pointing to next. Okay, we have to say one thing like this. So I'll say current equal to next, and next will be current dot next. Okay. Okay. The next will be current dot next, and then again it will check if next dot next exists or no. It doesn't exist. It will exist here. So first is the current here. Let's again, current is here. Next is current dot next here. Then what happens? Then current becomes next. Current becomes next. So current is going here. And next is going to current dot next. That means next is going here. And I check next dot next exists here. Yes, exists. Then I will follow again all the steps. Let's clear this. This is creating problem. Again, let's create again. I have to write down 100 times. I have to draw this one. So we have 1, 2, 3, and 4. Here it is 13, 4, 2, 1. So initially I assign the current to head. So this is current. I assign next equal to current dot next. That is, this is the next. Then I check next dot next exists. That means next dot next means this exists. Yes, this exists. Then what I do? To current equal to next. So current is next. That means current is moved to this one. And next is moved to current dot next. Current dot next is this one. So next is moved here. This is deleted. This is deleted. Now again I check whether next dot next exists. Yes, next dot next exists. Then I will do current equal to next. So current is moved here. This is deleted. And next is moved to here. So next is current dot next. Next is moved here. Then again I check next dot next exists. Next dot next is null. So I will say next dot next does not exist. Since next dot next does not exist, we will come out of the while loop. And since we come out of the while loop, current is now pointing to this one. And next is pointing to this one. Now only thing we need to do is current dot next equal to null. We have to point this current to null. But user wants to see which item was removed. So we removed this item. So we just want to return next. This one. We have to return this next. We have to return this next, that we removed this item. That is the next one. Okay, let's try to check if it is working properly. Now we have 13, 4, 5, 1. If I do list.pop, which item we should remove? Which item will be removed? Okay, 5, correct. Let's see if it is working. Okay, so since we return it, but we did not put the console.log, so we are not able to see it. I will do it next time. But see, 5 is removed from the list. Let's try to do the console.log. So let's put this pop inside console. Okay, so you will see 5 was removed. Let's try to do it again. Now 1 is removed. Let's try to do again. Now 4 is removed. We have not taken care of 2 conditions which we will take care of. Right now consider this will work for more than 2 elements if we have more than 2 elements. Okay, so don't try to play with less than 2 elements right now, because we have to put few conditions here to make it work for 1 and 2 records. So let's try to put the condition now only so that it is done. So for example, if we don't have head, that means it is empty, then we return null. That means there is no element, then we return null. And if we have only one element, that means we don't have this dot head dot next. So we have only one element, then what we can do, we can say, since it is only one element, we can just say this dot head equal to null and return it, because we need to remove that element. But if we have more than one element, then this logic will work fine. Okay, so just write down pop function, which is completed now. Okay, there is some problem with this one, this condition. We need to remove we want to return the element which we removed it. So we can do like this. We can say let or constant current equal to this dot head, and then we make the head null and we will return the current. Okay, because we need to return something what we removed. So we removed this head part. So we assign this head to current, we make the head null and we return the current. Since current and current both are in the same function, so I'm getting red mark. Write down just C, for example, here. Okay, that finishes our pop. So just write down this pop and we are done for today.